This is to show you knows for grade 9 math, continuation of rational numbers, section 2.3 in Math Links. It's how to add, subtract, multiply, and divide rational numbers in fraction form. So the first show you know gives us -3/4 take away 1/5. Okay, and the process for adding, subtracting, multiplying, dividing fractions is the exact same in grade 9 as it is in grade 7, except for now we have positive and negative values for fractions. So the process is still going to be the same. So the first thing we're going to do is we're going to find a common denominator for both fractions. Since 20 is the first one they share, we're going to create equivalent fractions, and that's going to be 15. Now it's going to be a -15/20. And what I'm going to get you to do is anytime you're dealing with positive or negative fractions, when they're negative, just keep your negative symbol up in with your numerator. It's the exact same thing. It just helps to keep things kind of universal. And then the second one, 1/5, if I find the equivalent fraction, it's going to be 4/20. And now this is a step that you kind of probably didn't write in grade 7, but you probably should have. The process now is when you have your equivalent fractions, you're supposed to, in this case, subtract your numerators and keep your denominator. So -15 take away 4. I'm going to think of that instead of using subtraction, I'm going to use the adding of the opposite, which is going to be this. And once I get that, my final answer, -15 plus -4 is -19/20, which is lowest terms, and is the answer. So as you can see, there wasn't a whole lot of difference. In grade 9, what I like you to do is show these two steps here, which sometimes we don't do. We kind of get the equivalent fractions and leave it at that and just get their answer. But show these two steps and get your final answer and circle it. In your second example, we have -2.5 plus 1 9/10. Again, we have mixed fractions. So there are various ways you can do it. I don't like dealing with the whole numbers first and then the fraction part second. I always like to deal with, just keep the mixed fractions as improper and work the same algorithm out as you did here. So I'm going to change -2.5 to -5/2, right? Remember, ignore this negative symbol. 2 times 2 is 4, plus 1 is 5, over 2, and then it's a negative, so put your negative up, like I said in the last question, in your numerator. Plus 19/10. So all I've done is I've changed both of those fractions to improper. Your common denominator will be 10, and your equivalent fractions will be this. Now we're adding fractions, so the rule is keep your denominator and add your numerators. A -25 plus a +19 is a -6/10. And in lowest terms, that will be -3/5. In your second show you knows, we have the multiplication of two fractions and we have the division of two fractions. And these are actually even easier because there's not a whole lot of difference at all with these ones. So if we think about -2/5, now notice why I put the negative symbol up in the numerator, and I'm actually going to use the multiplication sign. This is what the question actually says. If I was to multiply the numerators, I would go -2 multiplied by -1 over 5 times 6, and I would get a +2/30, which in lowest terms is 1/15. Okay, so your answer to that question is a +1/15. And actually what you could have done, since you're multiplying, is you could have ignored the signs altogether, because you know a negative times a negative is going to be a positive, and just multiply the two fractions together. Now alternatively, here in this part here, you could have cross-reduced. So remember, if I was to swap these numerators, so I'd have -1/5 multiplied by -2/6, I would still multiply the numerators, and I'd still multiply the denominators, and I'd still get -2/30. I'd still reduce that down to -1/15, or positive 1/15, which is what I got before. But swapping the numerators doesn't matter. But obviously, if I swap those numerators, the nice thing about this is I could reduce this starting fraction to -1/3, right? Because both are divisible by 3. And if I had have done that, when I multiply the numerators here now, -1 times -1 is 1, and 5 times 3 is going to be 15. I end up getting the lowest term fraction without having to reduce in the end. So I just cross-reduce. That was something you learned probably in grade 8. So reducing here, both are going to be divided by 2. I get -1/3, and when I multiply it out, I get -1/15. or sorry, positive 1/15. In the second show, we have division, so I'm going to approach the mixed fractions the same way. I'm going to change 2 1/8 to an improper fraction, which is going to be 17/8. And since it's negative, I'm going to put my negative symbol up there. Divided by 1 1/4 as an improper fraction is 5/4. And in grade 8, you learned the easiest way to get an answer to division is to multiply by the reciprocal. So we're going to put negative 17/8 multiplied by the reciprocal of 5/4, which is 4/5. Remember in the last question here, I said cross reduction. So check to see if you can reduce. So if I check this way, can I reduce these two fractions? The answer is no. Can I reduce these two numbers by a factor? The answer is yes. I could reduce it by 4. So I'm going to cross reduce that, and I'm going to just do it without. Both are divided by 4. I get 1/2. And once we get that, we're going to multiply our numerators. We're going to multiply our denominators. And we're going to get negative 17/10, which in mixed form is negative 1 7/10. All right, that's your answer, negative 1 7/10. Now, if you didn't cross reduce, let's just see what we have here. If you didn't cross reduce, you would have multiplied your numerators here, negative 17 times 4 over 8 times 4, and you would have got 40 plus 28 is 68 over 32. You would have divided it by 2 to get 34 over, I think I made a mistake somewhere. Did I make a mistake? 40, 68, 32. No, I think that's right. Over 16, which is going to be 2. Oops, I see my mistake now. That should be 8 times 5, not 8 times 4, you goof child. 8 times 5, which is 40. Divided by 2, I get this. That's going to be 1 14/20, which is going to reduce down to 1 7/10, which is my same answer before, negative 1 7/10. And your third show, Stefano had $46 in a bank account he was not using. Each month for 3 months, the bank withdrew 1/4 of this amount as a service fee. What a bank that is. How much was left in the account after the last withdrawal? So if we think about $46 or a quarter of $46, that's how much money he was going to lose in the first month, right? So a quarter of $46, or if we wanted to, a quarter of $46, you can either use fractions or decimals. If I use fractions, I'm going to consider the whole number to be over 1. I'm going to probably try my best to cross reduce this down to 23/2. I'm going to end up getting 23/2, which is going to be 11.5, or $11.50 was taken out of his bank in week 1. If I use the quarter of 46 using decimal form, and grab my calculator, a quarter of $46 is still $11.50. So if we think about week 1, we'll just put week 1, and I'll erase all this stuff here. If he lost a quarter of it, right? If he lost a quarter of it, it's the $46 that he had. Take away the service fee of $11.50. The answer is going to be $34.50 remaining. So a positive $34.50 is the remainder of week 1. In week 2, a quarter of what remains will be taken out. So it's going to be a quarter of $34.50. Or again, since we know that a quarter is a real easy number to work with, that's the service fee, a quarter of $34.50. And we're going to put a quarter of $34.50. And there's going to be $8.63 taken out as a service fee. So $8.63 approximately, because they're going to round up, is your service fee. So if that's your service fee, we're going to take the 34. Where's my calculator? There it is. $34.50. I'll bring it over here. $34.50, which is what remained in the bank in week 1. Take away the $8.63. After week 2, there is $25.87 remaining in the bank account. And finally, week 3, I just realized these are supposed to be months, but whatever. So a quarter of the remaining balance of $25.87 will be taken out as a service fee. So I'll grab my calculator. A quarter of $25.87 equals, there will be a service fee of roughly $6.47. So take my $25.87, which remains after month 2, take away the new service fee of $6.47, and what remains in the bank account? What remains, therefore, what remains is $19.40. Now, technically, because this is a fraction question, we should have used this method here, which would have been a quarter times 3450 over 1, and then I would have multiplied that out to get 3450 divided by 4, which would have given me 2587, or sorry, would have gave me 863, and then I would have subtracted that. So I could have used fraction forms instead, but obviously a quarter was one of those ones that was easier to use as decimal. So there is the show you knows for section 2.3.